We're going to look at two of the file input functions in MATLAB. First, fscanf. The format of using the fscanf function is you pass to it the file identifier, then a format string, and then the dimensions. And what the fscanf function does is it reads from the file identified by the file identifier directly into the matrix variable. It reads it in column-wise, so in other words, every line from the file becomes a separate column in the matrix. The fscanf function will read everything from the file in the matrix, so no loop is required. This, of course, assumes that we've opened the file first and have the file identifier. If the file contains both numbers and characters, what happens is that the characters are converted to their ASCII equivalents. Since a matrix always stores values of the same type in every element, all of the characters are converted to numbers, so the elements in the matrix are all numbers. Then, since every line from the file becomes a column in the matrix, that means that the matrix has to be manipulated if you want to get it back in the original form from the file. The format string specifies exactly how every line in the file is formatted, and the dimensions specify the desired dimensions of the resulting matrix. So let's take a look at these in a little bit more detail. The format string includes conversion characters, much like those are used in the fprintf function. The format specifies exactly how every line in the file is formatted. For example, if the file has the following format, where you have a number, a space, and a character, we could use the format string %f space %c to read in the number and the character, skipping the space in between them. Or we could use the format string %f %c %c, and that would read in the number and the space and the character. The dimensions specify the desired dimensions of the matrix. If the number of lines in the file is not known, then we can use INF, the built-in constant for infinity, for the second dimension. Remember, every line from the file is read into a column in the resulting matrix variable. For example, if the file has the following format, every line stores a number, a space, and a character. And if we use the format string %f space %c, that specifies that we're going to read two values from every line, so there will be two rows in the resulting matrix. But we would not assume that we know how many lines there are in the file, so we could use the dimensions 2 space INF. That will create a matrix that has 2 rows by C columns, where C is the actual number of lines in the file. Again, the use of the constant INF enables any number of lines from the file. So we're not saying that we have an infinite number of columns, but it will expand to however many columns it needs, again based on the number of lines in the file. So here's an example using fscanf. Again, if the file has the format where every line in the file has a number, a space, and a character, then we can specify, if we have the file identifier, that we're reading in a number, a space, and a character. And we're saying that the resulting dimensions of the matrix will be 2 by INF, which again means 2 by however many lines there are in the file. So in this case, there are 3 lines in the file. So what we end up with is a matrix that has 2 rows by 3 columns. So every line from the file, for example, the first line, 5.3a, becomes a column in the matrix. So first the 5.3, and then 97 is the ASCII equivalent of A. So the second line in the file is the second column in the matrix, 2.2, and the ASCII equivalent of B, which is 98. And then the third line in the file becomes the third column in the matrix, which is the number 3.3 and the ASCII equivalent of A. So what we end up with is a matrix that has 2 rows. The first row is the numbers from the file, and the second row is the ASCII equivalents of the letters. So if we wanted those actual letters, then we'd have to convert them back to characters. Another function that we can use to read from a file in MATLAB is called the TextScan function. The TextScan function, much like fscanf, also reads the entire file at once, so again we don't need any loop. What TextScan does is it reads into column vectors, and it stores the column vectors in a cell array. The general form is when you call the TextScan function, you pass the file identifier. So again, we're assuming that we've already opened the file and we have the file identifier. And you specify a format string, much like fscanf. The results are stored in a cell array. The format string specifies exactly how the columns in the file are formatted. So think about this in a slightly different way. Think about the file as being separate columns. You're specifying the format of each column, and each column from the file gets read into a separate column vector, and then all of those are stored in a cell array. So let's take a look at an example. So if the file has the following format, where every line from the file has a number, followed by a space, followed by a character, we can think of this as being two separate columns. So we have a column in the file that has numbers, and then we have a column of the spaces, and then we have a column of the characters. So think of it as columns. So when we're specifying the file format string, we're saying that we have a column of floats, and then we have a column of spaces, and then we have a column of characters. So what happens is that the TextScan function will read the first column, which is the numbers, into So what happens is that the TextScan function will read the first column, which is numbers, into a column vector. So that's this 3x1 column vector. And it will read the column of characters into a 3x1 column vector of characters. So now my variable here, subjdata, that's a cell array that stores the two column vectors for the numbers and the characters.